I received a request for an optimal product mix problem. So let's look at the case information that we're given. This company makes two different types of candles. They make large candles and they make small candles. Whenever you're doing a problem that has to do with optimal product mix, we have to factor in the component of time. There is always some type of constraint when you're doing a problem like this, so we're somehow limited. Most of the time, we're limited by time. Because if you just looked at this, you would say, well, my large candles contribute $8 per unit, and my small candles produce $6 per unit. So why don't I just make more large candles? Because they contribute more. Well, let's see what our constraint is in this problem. It says all candles must be chilled in the fridge. So we have this fridge here in order for the candles to set properly. The company only has one fridge. Oh, that sounds like a constraint. Because of the size of the large candles, the company can cool 6 cases of large candles per hour, and it can cool 9 cases of small candles per hour. The company can sell as many candles as it can produce. The fridge can be used 180 hours per month. So we only have 180 hours, and both of these types of candles need to go into that fridge. So rather than looking at contribution margin per unit, let's look at contribution margin per hour and see which one of these products would make us the most money per hour. So let's look at large versus small. My contribution margin per unit is 8 for large and 6 for small. How many cases of candles can I make per hour? So let's see, cases per hour. Well, I can make 6 cases of large or 9 cases of small. Remember, I can't do both. I can only do one or the other. So if I take and multiply these numbers together, I get CM per hour. So for large, I get $48 per hour, and for small, I get $54 per hour. So now, if my goal is to maximize my profit, I want to make the units where I'm going to make $54 an hour, because then I'll make more money in the 180 hours I have. So if I were going to make a product, I'm going to make the product that makes me the most money, which is small. Well, how much money can I make? Well, let's take a look. If I can make $54 per hour, I have 180 hours times $54 per hour. I can make, my contribution margin would be $9,720. Contribution margin. Okay. Now, how many units is that? Well, if I take 9 units per hour times 180 hours, so I can make 1,620 units. Okay, that's how many candles I can make. I can make 1,620 candles, which would give me a contribution margin of 9,720. You could also take the 1,620 and multiply that by 6, which would also give me 9,720. Okay, so there's 2 different ways you can get that contribution margin. My fixed cost is 6,000. So my profit is $3,720. Now, what happens if we put another constraint in here? Let's look at question number 2. What if the company can sell no more than 1,350 cases of either type of candle? Well, we just said that if we made all small candles, we could make 1,620 cases of candles. Well, that's more than 1,350. Are we going to make more candles than we could sell? Probably not, because we could have those extra candles sitting in inventory, but they're not going to generate any revenue for us. So what if instead we made 1,350 cases of small candles, maximize the revenue from that, and then use the excess capacity to make some large candles and generate some income from that? So how do we figure that out? Well, we can sell 1,350 cases of small divided by 9 cases per hour, and that gives me 150 hours. So it takes 150 hours to make 1,350 cases. If I have 180 hours total, that means I've got 30 hours left to make large candles. Well, how many candles can I make in 30 hours? Times 6, because I can make 6 cases per hour. So that's 180 cases of large. So that means I'm going to make 1,350 cases of small and 180 cases of large. So let's get some more room here and let's figure out what our profit would be if we made this mix instead. I've got 180 large and I've got 1,350 small. Times my contribution margin. Let's go back, scroll up. My contribution margin is 8 and 6. 8 for large, 6 for small. That gives me 1,440 and 8,100. Okay, and notice that my contribution margin for small, because we're only making 1,350, is lower than the contribution margin that we had before, because we're limited to how many units we can make. So if we add together our contribution margin, my total contribution margin is 9,540 minus my fixed cost of 6,000. That gives me profit of 3,540. Okay, so now that's less than what we came up with before, right? Because my new profit is 3,540. My old profit was 3,720. So remember, we said that the more small candles we can make, the more profit we can make. So if we're making fewer smaller candles, then our profit is going to be lower. That is how you do an optimal product mix problem. First with just the time constraint, then with a sales constraint as well.